Hello, grade 10. This is Mr. G, and we're going to make a video on a question about ionic bonding. Okay, so this question said, look at the following ionic compound. And we have two ionic compounds, KCl and CaCl2. Okay, so the first question said, write down the valence equation for the formation of each ion in compound B using Lewis dot diagram. 1.2 represent the formation of the ionic bonding in each compound using Lewis dot diagram. 1.3 write the name of each compound, and 1.4 calculate the relative formula mass for each compound. So we have the two compounds there, and here at the bottom we have the periodic table. Okay, it is very important. So let's begin by writing down the valence equation for the formation of each ion in compound B. So let's write compound B here at the bottom. First is Ca Cl2. So is CaCl2. Let's first of all identify what ions make this specific compound. This compound is made from calcium. There is calcium, and is made from chlorine, and there is chlorine. Okay, so let's go back to the periodic table of the elements and record something important here. All the elements in group 1 will form ions with the form X is 2 positive. All of them in the group 1 will form ions with a positive charge. All of them will form ion with a positive charge. All the ions, all the atoms here, no ions, all the atoms in group 2 will form ions with the form X2 plus. So all of them will actually lose 2 electrons. So all these ones will lose 2 electrons, right? All the atoms in group 17 will form ions in the form of X to the minus. They will gain 1 electron. Now all the atoms in group 16 will form ions in the form of X 2 minus, because they will gain 2 electrons. So this is important. Here in group 3 will be a 3 minus, and in group 13 will be a 3 positive. Okay, but these are the main ones. Now let's look for calcium. The first one we find is calcium. So calcium is going to be here. So at the end it will form an ion of Cl2 plus. Okay, however, to do in Lewis dot diagram, we have to identify the number of valence electron. Now the valence electron also, to record, remember the valence electron is the same as the group number using the Roman number. So all these ones here will have this specific number of valence electrons. All right, so we are talking about calcium. So calcium will have 2 valence electrons. All right, so let's go here and let's go to calcium. Calcium have 2 valence electrons, 1 and 2 valence electrons. What is calcium going to do? Calcium loses electrons, and is going to lose those 2 electrons, and therefore calcium will come Ca2 plus, as we saw in the periodic table, and the 2 electrons must be added there. So this is the first question for calcium, which is the first ion. The question said, write down the valence equation for the formation of each ion in compound B. The first ion in compound B is calcium, and here is how the ion is formed. Note, this is the ion. Okay, so this is how that ion forms. Okay, so let's go now to chlorine. Let's go to chlorine. Now let's first of all do it here on the next. We have enough space for that one. All right, so we're going to do chlorine here. We're talking only about chlorine. Now if you determine where is chlorine in the periodic table, chlorine is here, is in group 17. It will have 7 valence electron and will form an ion of negative. So you must have that in mind, because it will help you to determine if the answer is right or wrong. Okay, so we have chlorine, the symbol is Cl, and it have 7 valence electrons, 1 2, 3, 4, 5, 6, and 7. Alright, now what does chlorine do? Chlorine gain electrons. It gain 1 electron in this case. Okay, chlorine gain 1 electron and it becomes Cl now with the 8 electrons. It doesn't have 7 no more, it have now 8, and then because it gained 1 electron, the charge of chlorine will be -1, and remember we only write the minus because it's 1. So this is for chlorine. So this is how to represent the valence equation for the formation of chlorine ion. Note this one here is chlorine ion. This one is the one we're talking about. Okay, so let's go to the second question, 1.2. Now, question 1.2 said, represent the formation of the ionic bonding in each compound using Lewis dot diagram. So we are talking about the whole compound now, not only the ion. So 1.2. Let's go to the first compound, which is KCl. It is KCl. So we have to represent how KCl forms. That is the compound. So we're going to use Lewis dot diagram. Potassium has 1 valence electron, is in group 1. There is potassium. There is potassium. It has 1 valence electron, and therefore we represent potassium with 1 dot. Plus Cl. Cl, we just saw it. It has 7 valence electron. So what is going to happen? Potassium is going to give that electron to chlorine. So this electron here is going to be transferred to chlorine. Alright? So it will be transferred to chlorine. It will be transferred. It will form the potassium positive. Chlorine will form the Cl negative. But the electron is going to be transferred to chlorine. So what do we have in the product? We have potassium positive because it did lose that electron that had before. We have Cl with the 7 valence electron plus the 1 that is coming from potassium. Okay, and then this is becoming negatively charged. We need the square bracket because it has too many valence electron. Alright, so all this one is negative charge. This one is how to represent the formation of potassium chloride using Lewis dot diagram. In the exam, when you doing exams, you will have marks 1 for maybe each ion plus 1 for the final formation. Okay, so let's go to the second compound. Now the second compound is going to be CaCl2. We already work with that specific compound, CaCl, and this is question 1.2. CaCl2. So what do we have? We have 1 Ca. Remember the valence, we just work with Ca is 2, and you have Cl, but you have 2 Cls. So Cls 1, 2, 3, 4, 5, 6, and 7 valence electron, and you have another Cl 1, 2, 3, 4, 5, 6, and 7 valence electron. You have 2 Cls. So what is going to happen here? The electron of calcium 1 will be transferred to one of the Cls that needed there to become full like a noble gas, and the other electron will be transferred to the other Cl. So what are you going to have at the product? You will have Ca that has lost 2 electrons, therefore is 2 positive because 2 electrons are gone. And you have 2 Cls that have each of them 8 valence electron. Now is full, but you have 2 of them. And each of them is negative. So you have 2 Cls with a negative. And this is how the formation of a CaCl2 using Lewis dot diagram. Okay, so let's go to the next question now. The next question here said write the name of each compound. Now, to write the name, we're going to recall quickly what we learned at the beginning of the year. Okay, so for question 1.3, the first compound is KCl. KCl. So you have to go to the table of ions. It is done in class. Okay, the first ion is K plus. You even have it here represented in the first one. There is the K plus, and now K plus is called potassium. Potassium. Let's just fix this one. Potassium ion. It is called potassium. And Cl here, this Cl is coming from, remember, potassium ion is K plus. We already spoke about that. And Cl, this Cl here is going to be Cl minus, and it's called chloride. So the name of the compound is a combination of both potassium chloride. So the final answer for this first compound is potassium chloride. That is the final answer for the first compound A. Okay, working with compound A. For compound B, it's similar. For compound B, we have now Ca and Cl2. Cl2, and then you have to look for the table of ions. The first one is calcium. And the second one is chloride. Remember, chloride is Cl minus, calcium is Ca2 plus. We have the representation here at the first question. Okay, there you go. So when they combine the names, we have calcium, chloride. The number is not part of the name. So this is question 1.3. Let's go to question 1.4. All right, question 1.4 is said, write the name of each compound. Question 1.4, calculate the relative formula mass for each compound. So relative formula mass for each compound is quite easy. 1.5 of 1.4, sorry. 1.4. So let's write the first compound. Compound A is a KCl. So all you have to go is to go to the periodic table and calculate the relative molecular mass, in this case formula mass, of KCl. Alright, so for KCl, let's go to the periodic table and look for the mass of potassium. Potassium is here. The mass, let's just take off this. There, you can see the mass in this specific periodic table is at the bottom. So for potassium, it's going to be 39. Okay, so the mass for potassium is 39. So this is going to be 39 plus the mass for chlorine. You go to the periodic table and chlorine is right here. It is the number at the bottom. You can see is 35,5 in my periodic table. All right, so 35,5 plus 35,5, and this is going to be equal to 74,5. Let's write unit, but the actual mass is grams per mole. You will learn about that in other moment. Okay, for now you can write unit. All right, so that is for A. I think it's quite easy. Let's see for B. For B is Ca Cl2. So we have to look for the mass of each of them in the periodic table. So for calcium, let's write here mass of Ca Cl2, and then the mass for calcium in the periodic table. Let's look for it quickly here. Is 40, you can see it there quite easy. It is a 40. We are here, 40 plus chlorine, which is 35,5. However, note you have 2 chlorine. Okay, so it's 2 times 35,5, and that will give you the mass of the formula unit for this specific compound. And the answer is 111 units. Sorry, 111. The actual unit is gram per mole, but we're going to speak about that later. So for now, you can keep it in unit. That is how to calculate. I hope this video helped. It is useful. It's an example of ionic bonding. Good luck. Thank you for watching, and I'll see you next time. Thanks a lot.